So if you watched my shop rearrange video, I mentioned something about moving more tools because a change might be coming. The change has arrived. This is a CNC router, obviously. I'm not sure how to say that. Cielle, maybe? Alpha 80 by 120. I'm guessing that is the millimeter dimension, in which case it would be just over 3 feet by just over 5 feet. And the table itself is actually, I want to say it's 35 inches. So it may travel just a little bit outside of that. But it's just under 6 foot. So obviously the end of the gantry doesn't go past the table. So that's going to eat up some space. So anyway, 3 by 5 is general size. This control box here came with it. It's going to be just for parts though. This is what it looked like. But I knew this was not a surprise. I knew this. So, I mean, that's not encouraging. Thinking that we're going to get this thing going as it is. So, no biggie. The plan is to do a retrofit, just like the Herco and the hard-hinge lathe. Came with this, which is a spare spindle motor. So that's either good news, I have a spare, or bad news, this one's shot. But either way, if it's bad news, then it's still good news. I think that's a ER collet. Not sure. I have to get it apart to see. But if it is, I don't think it's a 32. Whatever's under that, is it like a 20 or 24? Can't remember. Got these coolant nozzles. Now, it's cool, it's got this trough all the way around on both ends, and then it's got this here. No drain for it though, so I'm not sure what the intention is. Maybe it's a mist, and it just collects it and lets it evaporate. You got me. It's got this little line here, also going to the spindle. First thought, I was thinking it was coolant, but there's no return line. So maybe it's just air blast to help keep it cool. Don't know. These linear rails here look pretty good. That one, and then there's one back there. It's a big piece of cast aluminum. I mean, this thing's pretty heavy for what it is. These two end plates are 1.5 inch solid aluminum. They made those out of. So aside from the control box, like I said, which we already knew, these linear rails here might be a problem. You can see they're a little grimy. I'm gonna try some professional rust product. Maybe I don't know, like a Rusty's. That's not real. That's from TV. Evaporust, or maybe vinegar or something. One of those two. Try it out. Scotch-Brite it afterwards. See how it looks. If it cleans up, I'm gonna run with it. If it doesn't, then it'll be a bummer. I have to get some linear rails. The other known issue is the X-axis lead screw. And this machine does have lead screws, so I'm gonna have to decide if I'm gonna keep that or switch it over to ball screws. I don't know. Seems like a professional machine, and it came with lead screws, so maybe I'll just let it slide. But this one's broke off, sheared off down here, so I don't think it can be fixed. And it's all bent up on that end, so we'll just assume we'll have to replace that. And I knew that. That's no surprise. So no big deal there. Got the gantry tied off so it wouldn't, because of that lead screw, so it wouldn't shift around while it was on the trailer. So I think what the plan is going to be, pull off all the guards, everything that's unnecessary for function, just to get down to the bare bones, because it's going to have to be completely rewired. Obviously the rails need some attention. I think I want to do this transparent, and just keep a tabs on how much everything cost, so that at the end I can look and see exactly how much it was to retrofit, to buy, and then to retrofit this, and then see how it compares to maybe a comparable machine, a new machine. But the machine itself, as it sits right now, was $1,500, which that's a lot of money, but it's a good start, man. It's a good start. If I don't have to replace those rails, that'll be great. Just the lead screw and the electronics, I'm gonna guess it's gonna be around another $1,500. So maybe $3,000. I don't know. See how close I hit that. If I get close to hitting it. If I have to replace those rails, probably closer to $3,800. All in, everything. So this is it. Just got it home today. Just barely have a spot for it. Once I get it up and running, it'll go towards the back of the shop somewhere where it's out of the way. But this is where it's going to sit while I'm working on it. Hopefully it'll be pretty quick. So I figured the first order of business would be to sort out the X-axis lead screw. So as you can see, I got this cover piece off here. This is the back side of the flange, and this is the screw itself. Obviously that's not going to work. From best I can tell, the other end, it's threaded and tapped, and it looks like whatever bolt they had in there to hold it sheared off, which caused the end to whip around and did all of this. Good news is I can get I'm still debating, but a ultra precision lead screw, same size, and a matching nut, maybe around $260, which, I mean, that's still a lot of money, but a ball screw would easily be double that with the nut. And I think this is the motor assembly that I pulled out. Let me flip it around here. So here's the motor, and obviously it spins this whole assembly here, which is where the flange to the ball screw is supposed to match up. But of course mine is broke, so I can take this, and if I can't find an exact match, I've got enough room I can drill and tap it. And if I have to make a little adapter sleeve or whatever, I can make all that work. So that's not a big deal. So I think I have a solution for the X-axis. But while I was at it, trying to figure out this motor here. Hold tight. This motor is a Stepson. I don't know. This machine's probably 30 years old. I know the motor's discontinued, but it's not the typical DC motor that I'm used to seeing, which has basically a positive, a negative, and then some encoder wires. This has 8 wires, all ganged up into 4 selections. I think it's like a bipolar stepper or something like that. And no encoder, which is kind of a bummer. So I'm not sure if I'm going to use these motors or not. I'm leaning towards no. Of course, I'd like to save the money, but if I'm going to do this, I don't want to do it once. So, not sure. While I was at it, I got this cover off, which goes over top of the gantry, so we can see what's going on in here. As you can see, there's a little bit of uglies on the linear rail, except for where the carriage was sitting. That is really nice. So I'm gonna get some rust stuff and some Scotch-Brite, see what I can do there. There you can see the motor. All 3 of them are the same. Got herself a little, I think those are ants. Anyway, let's deal with that. And also, it appears, see if I can get some light in there. Appears to me that that's sheared off as well from the flange, because the flange is over here and the nuts not matching up. And this thing is really sticky, so I'm gonna have to load it up with something to clean it off. I'm hoping I can find a nut that's a similar size, because this one sits on the inside, which means it has to pass through that hole there. It'd just be a lot easier if I can find an exact replacement. I don't think there's enough room out here. Well, maybe on this side, because this motor's in the way. So if the flange was here and the nut was on this side, that might be okay. It's got these little rubber bumpers to keep it from going too far. Another concern is, if I do replace the motors, I've only got a certain amount of space here to work in without causing a problem. Same thing on the Z. I mean, I can go a little bit bigger, maybe ½ inch or an inch, but I don't want to lose any travel. So, still sorting that out. But one step at a time. I think I'm going to take care of this first and try to figure out what motors are available to get some pricing. And I've used a DMM Tech on the hard hinge, and that worked out great. I love those motors, so that may be an option. And I just noticed there's an adapter plate here to mount the motors, so that's convenient, because it's almost certain the motor is going to have a different bolt pattern. So to make them fit, as long as they fit inside these mounting plate holes, should be golden. And that one's got it too. Okay, cool. Just noticed that. And obviously this one, that's how it's mounted. Bridges that gap there with that plate. So, okay. I know what to do next. I found a little surprise under this cover here. Looks like at some point somebody had taken up residence in here. Doesn't look like any of the wiring got hit though, so I guess that's good. So like I showed you, the linear rail is a little rough. It's not terrible. It's actually really good compared to the side rails. But this one's the easiest one to get to. And of course there's one right on the front down here. But I think I'm going to try this one first, get my technique sorted out, and then we'll, if it works, which I don't see any reason why it shouldn't, then we'll move on and do the more difficult ones. So what I think I'm going to do is take some of these blue shop rags, bought myself some Rusties several years ago, never even opened it. The label's even falling off the bottle. It's been around so long. I'm going to try this technique, see how that works. let this kind of soak in all day while I'm doing other stuff. And I got a green Scotch-Brite. Depending on how this looks at the end of the day, I'll come back with that and see if we can hit it with that. See how that does. It's pretty much been up here all day, about 12 hours. Let's see what we have here. Feels pretty good. It's got a little bit of staining. So this is what we started out with. Very light surface rust. And now we're down here. Admittedly, this section was not quite as bad as this. Stupid, I probably should have did that while I was at it. But anyway, one more thing I want to do. Hit it with some WD. And then a green Scotch-Brite. Let's see what happens. Well, I gotta say that feels pretty good. Look at that. That cleaned up nice. So I've already, the front was just a little dirty, the one on the front. So I hit that already with WD and a Scotch-Brite, and it came out just as nice, maybe even a little nicer. Let's see how the now that this section is clean, at least about 2 feet of it, let's see how the head feels when I move it. I'm going to have to get the flange to that lead screw off first. Let me tackle that real quick. So I knew about the X lead screw needing to be replaced, so that wasn't a surprise. What I did not know was the lead screw nut for the Y-axis. The flange is actually sheared off from the rest of the body. It's 20-year-old, whatever kind of plastic this is, so I guess I shouldn't be surprised. I might see if I can repair this. I've already looked and I can't find one that matches this thread exactly. Not sure why. Maybe it's old. Maybe it's tie-in and not available. I don't know. So I may end up having to replace this lead screw just so I can get a new lead screw nut. But if I do, I'll buy a couple spares. So I don't know. Not ready to cross that bridge quite yet. If I can't get it to glue back together, maybe I can make some type of a flange that mounts here that clamps to one end of it. I don't know. We'll cross that bridge. But for now, let's just see how this thing moves with the clean rails. That's nice. Yep. Yeah, that is nice. Okay, good. A little bit of effort. Man, it's got some weight to it, obviously. But it doesn't feel like I'm pushing through anything. Man, that's cool. Okay, good. So we'll park this right here in the middle. I'll tackle the rest of these rails. And I'll go ahead and start on the ones on the x-axis. I need to let them soak. Probably longer than I do up here. But I don't know. We'll find out. So once I get those cleaned up, we'll bring it back in. And those are the ones I'm worried about. They're a little rougher. Come back in and see if they clean up. I'm hopeful, but I don't know. So, alright. Let's do that. Well, it took about an hour and a half of cleaning. But there's the result. A couple hours under some soaked rags. Cleaned them up. Once I took those off, I did have to hit a few spots with the brass wire wheel. But then after that, it was a Scotch-Brite and clean it down and then oil it up. So let's see what we got. I'll take that. I will take that. I also got delivered the other day, yesterday I think, brand new lead screw and nut. This is going to be for the x-axis, so that's the long one. While I was working on this, I pulled the y-axis lead screw out because this flange was broken off. Now, I was thinking about trying to glue it because it will index and go back where it was. It's broken off in a way that you can feel it. But the problem is there's nowhere for the glue to go. If you put it in between the two parts, there's no room for glue. If it smushes out, it's going to be in the way because it sits in this recess here. So what I'm thinking about doing, this may be a short-term solution. Actually, I'm not sure. I'm going to try to get in touch with the company and see if they sell just this, but they don't seem to have an American distributor. So if I get one, it'll have to come from Italy. So that may not be worth it. The other option I was thinking was to glue all these bits together on this end, which would normally have been attached and concealed down in there. Glue them together so they don't come apart, because these, you can see the seam there where these two pieces come apart, and then making a clamp that bolts in here. It comes out and clamps around this part and just holds it on this end. Now that wouldn't I don't know, that might not be a long-term solution. Or maybe it would last forever. I don't know. But that's another bridge I gotta cross. Or I might just spend the money, get another lead screw. The problem is, this lead screw is precision machined on both ends. Now I do have the CNC lathe, but I don't know about a 4-foot piece of material sticking out of the end, so I'd have to figure that out. And the new lead screw is stainless, 303 stainless, so I've cut that before. That's not a huge ordeal. I've got that pretty much figured out. So I'm not ready to cross that bridge yet, but soon. The other issue is these motors. I don't know if they work. I'm just guessing that they do. Can't see the tag on this one. We can see it on that one. Stepson from Sanyo. Anyway, it's a stepper motor, as would be expected, and something like this. I don't know if all three of them work. I guess you can check them with an ohm meter somehow. So here's the options. I can get like a PMDX board and some geckos, and I can run these, get a power supply and all that, and that would work. That's okay. That's what I did on the Herco, and it's fine. The Herco being my first one, though, I didn't really know what I was doing. I'm okay with it because it's working, but there have been occasions where I had said, man, I wish I had just went with something a little bit nicer and upgraded the motors. I've already had to buy one motor. It's 30 years old. These are 20 years old, so I don't know. The other option is to use a motor. They don't sell it in a kit, but a kit of parts to make a kit from DMM Tech. And that's who I used on the Hardinge, and zero problems. Those work great. Cool thing about them is it's pretty much plug and play. All the wiring and everything, you can get everything. Breakout board, drivers, motors, everything plugs in together. The only thing you have to do is hook the computer to the breakout board. The price difference is about $1,500. If I went the first route, reuse these motors, I'd be right in at my target, right under $3,000. Obviously, if I go the other way, we're going to overshoot my target. So I'm not sure. I got to cross that bridge too. But anyway, that's where we're at. Now, to figure out what to do next, it's probably going to be putting in this lead screw down here. I didn't want to put it in until I figured out what to do with the motors, though. Because if I change the motor, I could just mount it while this thing's out. I don't know. I'll have to figure that out. I've removed the motor from this bracket here, mainly because I knew I had to drill out these holes, or drill a new bolt pattern, because of course these holes are off by a tiny little bit. So I'm going to have to drill 3 new holes. This spacer was on there too. Not exactly sure what that does, because I don't know, maybe it was for the old lead nut. That must be it, because the old lead nut nested inside of there. So I don't think I need this anymore. I'm going to leave that off. This was really, really tight, but then I basically filled it up with a mixture of WD and PB Nut Blaster, and now it moves smoothly. wasn't going to take it apart to drill these holes, but I don't know how well, or if you can see that at all. It's got a tiny bit of backlash in it. So my guess is it's 2 ball bearings, 1 on each side, and the slop is in the ball bearings. So I'm hoping what I can do is take this apart, or maybe even tighten it to draw those 2 inner races together to take up the backlash. But if I'm going to do that, I might as well take it apart so I can drill it proper. So I guess that's what I'm going to do next. Looks like the x-axis is going to be first on the list. Get that done and work my way up. So go ahead and pull it apart. Okay, there's one. There's the other one. Boy, they were stuck. Can't believe they used bearings that weren't sealed. Given the environment these things were intended to work in. Strange. It's what now?
It's still pretty cold out.
So it's going to be around lunch before it'll be nice. It'll make it easier to drill and tap those, having that out. Here, looks like that's exactly, oh Lord, that one probably needs replaced. That is pretty bad. Well, if I'm going to replace them, I might as well use sealed bearings. That one's pretty sloppy too. Wait a minute. So there's a shoulder here and a shoulder on this side. So I'm guessing I can tighten this enough to take up that slack, just in case I can't find new bearings. We'll check that out. First we got to drill and tap. I couldn't help myself. I had to pull one apart, and of course, now that I have such a dummy, these are angular contact bearings. So they're made so that you can do exactly what I said, which was to tighten this to apply pressure from both sides to adjust the end play. Okay, no big deal. So I'm gonna clean them up, get all this goo out, add my own new goo, and probably get a part number off them before I put them back together. That way, in case there's an issue, I'll have it for reference. But it looks like we're okay there. So moving on. So I've made a little bit of progress on, I'm not sure what this is called. I'm going to call it the X-axis carrier assembly. Motor mounts here, and it looks like it did before I took it apart. With the motor here and the spinny thing here and the screw thing going through there. You get the idea. Anyway, I took it apart. Well, I got at least one of the bearings out, and it was really kind of gross. So I'm going to clean this up, and I'm going to clean the other one up, take it out and clean it all up, re-grease it and everything before I get it back together. But the big thing about this is this piece here, which you may remember sat here, and we had a pulley on the back side and the original nut on the front, which bolted into those three holes. Well, obviously I've drilled and tapped for the new holes for the new lead nut. Yeah, that sounds good. Lead nut. So this assembly is ready to go back together. I've decided I'm gonna sort out the X-axis first because it's underneath. Get that one done first, get it out of the way, and then move on to the stuff that's up top. Okay. So I did that. That's where we are on that item. I made a pair of these, one for each end, and where they go, it's starting to get dark out, so I'm not sure if you're going to be able to see. They're going to go right here and replace these things. Now, these bolted in just like these do, but the end of the lead screw was machined so that it could fit in here, and then it had a screw on this end and a screw on the other end. I didn't want to do that. I'm sure the people knew what they were doing when they built the thing. I was scared to do that for two reasons. One, I didn't want to screw up an expensive lead screw. But the other thing is, if you're tightening on both ends, aren't you stretching that screw even a tiny bit? I don't know. Maybe it's not a big deal. Probably not. But by not machining it, what I've come up with is this clamp assembly. So, here we go. So let's just say this is the end of the lead screw. Full diameter, which was 1/8 inch. It's actually like 0.489 or something like that. Comes through, and this tightens down. As you can see, it's connected here, but it's not connected around the top. So it will flex. and pinch that down. And it's wide enough here, I think that's 1/2 inch. It's wide enough that it should get a grip, a pretty good grip on that lead screw. And if it doesn't, then I can go back. I can still reuse these, and I can machine the ends of the lead screw. So that's where we are with that. Now I know I threw out a number as a potential grand total for refurbing this thing, and I was really hoping to hit that number, but I made a call and I ordered some stuff. Let me get you set up here. And as we're doing this, I'll tell you why I changed my mind. One healthy size box from DMM. As you can see, it says what's in there. And a slightly smaller, but no less heavy box. So I've decided to go with all new motors. I knew I had to get new drives. That was a no-brainer. We knew that. I was thinking about reusing the motors. And going this way was certainly more expensive. But here's the reason. With the hard-hinge lathe, I went with everything new. I mean, obviously all new electronics, but even new motors. With the Herco mill, I went with all new electronics, but I reused the old DC servo motors, which means I could use the Gecko drives, which are pretty cheap, and the PMDX board, which is not expensive. But the wiring was way more difficult on the Herco. On the Centroid, on the hard hinge with the hard hinge, everything was a whole lot easier as far as wiring was concerned. So there's a bonus there. The other thing is, this is basically a whole kit. This is, aside from the PC, I think this is everything I need. So let's crack it open and see. So I paid a little extra money, and I hope it's going to be worth it in the end, as far as performance and ease of getting this thing up and running. So, obviously these are the servo drives. I won't open all of them, but I am going to open one. And this is exactly the servo drive that I'm using on the hard hinge. Very, very cool. You can wire this straight to 110. You don't need a separate power supply for it. So set up a little fuse box for the power, and you're off to the races. It'll never go back in there the way it was before I took it out. I guarantee it. So we're just gonna do that. So 3 axes, 3 servo drives. Actually, I haven't even opened this to make sure they sent me everything. So you're seeing it for the first time, just like me. Those look like encoder cables. Plug and play on both ends. There's 3 of them, so that's good. Okay. This is for going from the breakout board to the drives. Plug and play on both ends. Ah, look at that. That is the breakout board. That is way smaller than my PMDX, and my Centroid board is bigger than that too. It's supposed to work with it though, so we'll see. This is a small power supply. Just 24 volts. I'm going to use this one for relays, for turning stuff like coolant and probably the air blast with a spindle. And this is the bigger one. Needed this one for the breakout board. Seems weird because it's got 48 volts coming in, and it also has 5 volts coming in from the computer. So I don't know, maybe the 5 volts just tells it that the computer's powered up. I don't know. You got me. I don't even know what this is. I can't remember what I ordered. These guys are in Canada. On the other side of the, somewhere above Washington, I think, which is the opposite side of the country. I want to say I ordered these Saturday, and these are here the following Friday. And one of those days was a holiday. Oh, look, it's one of the motors. Yes, 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 yes. Very, very cool. Yeah, that is nice. Plug and play. Just hook it up. And you're ready to rock and roll. Oh man, this is cool. I'm ready. I'm ready to. It's like nighttime, but I'm ready to play. Let's see what's in the other box. I'm gonna guess it is 2 more motors. I'm gonna guess it's 2 more motors and some more wires. There we go. Okay. These appear to be the power motor, power wires. Yep. To go from the drive to the servo. Plugs on both ends. This is the third one. Okay. So there's 2 in here and 1 in here. Got it. And 2 motors. I think that's everything. I think we have everything. Okay. So, well, that's that. First thing I'm going to do is try to get this X-axis carrier. But oh, I have to make motor mounts. It was an extra, I want to say it was $60 extra per motor to get the exact same motor, but in the frame that would fit these mounts. I don't understand that. But it was the exact same motor. I looked at the specs and everything. So I bought the cheaper ones, and I figured for, oh, maybe it was $40, because it was $120 total. I figured for $120 I can make 4 motor plates. That doesn't bother me at all. So that's the first thing to do. Get this carrier back together with the spinner thing. The spinner motor transmitter doohickey. Mount a motor to it. Start slapping this thing up under the machine. Cool. So obviously I got the X-axis carrier together. I thought I was going to be able to use this. It turned out the holes lined up exactly for the motor. So I don't know what I was thinking when I said that that it didn't line up. The problem was the center hole was too small. So I put it in the mill and milled it out. I don't know what happened. It came loose, something shifted, whatever. It turned into an oval instead of a circle. But it was still pretty snug, but all the holes were shifted to one side or the other, depending on which way it was pointed, just enough that you couldn't get threads in. And the small bolts that held the motor in went right through the holes, in the mounting holes of the motor. So obviously the motor's supposed to have bigger screws holding them in. So I was gonna try to over drill these, but they were offset, so I couldn't do it with the drill, because then the drill would just walk, and I didn't have a mill small enough, so I cocked it just a little to the side, and it worked out fine. I had it bolted up, ready to put it in. I slid it in here, and it interfered with the frame. So I thought about clearancing the frame, and this is stupid. I already had the file. Let's just go ahead and whip one of these up. So that's what I did, and it worked out pretty good. But for the other two axes, now I know what I'm doing. If I can just, I don't know what happened, how it shifted, or I don't know, doesn't matter. Anyway, the other two axes hopefully will be easier, and if they are, then I can just use the plates that I have. So anyway, obviously got this mounted up, got the pulley, I bored it out because it was too small, and I broached it. Fortunately, I had the broach, it was the same broach size for the hard hinge, even though the motors were smaller. It's the same size key, so that worked out. I didn't have to worry about tracking that down. And I got this back in, all greased up, cleaned up, then greased up, put back together, and no play. So that's great. I'm gonna wait to put this on because it's plastic, and I guarantee I will break it. So I'm gonna put this on once it's in the machine, and I'll actually probably thread it to the lead screw first, get the lead screw mounted, and then just kind of walk this thing up to the back of this. Okay, so X-axis almost down. I just have to install it and then put the lead screw in. Run the wires, and the X-axis will be ready to test. Yeah, that's where I'm at. Just for reference, I think right now, at the point of the project, I am about 6 hours in. That's cleaning the linear rails, dissecting all this stuff, making these, coming up with files, doing everything in here, cleaning all this stuff. Everything to get me to this point, minus picking the machine up, obviously. That's just a variable. I just want to see how much time it takes to get something in my possession retrofitted. So right now we're hovering about 6 hours. I think I said 40 was my guess. Let's see how close we hit to that. So I got rolling pretty good this morning. Didn't want to stop. Got the X-axis lead screw mounted, and it's holding tight. So I think this is going to work just fine. I'm going to lop off what's hanging out here. It would probably fit behind this cover, but I'm going to take it off and put it in a lathe and see how hard it is to machine this end. I don't really do a whole lot of stainless, but we'll just see. Because if I have to replace the Y-axis, I want to know ahead of time how hard, because it's it's different than this. The Y-axis actually turns the lead screw, where this has that carrier that turns. So if I replace that axis, I will have to machine the ends of this. So before I put this in, though, I had to get the carrier put in. So I got that mounted. Now the only thing I did not hook up the lead nut. It's just kind of hanging out back there. That way I can move this to work on it without having to worry about trying to turn the axis itself. I also get the other two motors out, and I'm going to try. I'm going to try to reuse these plates, this one and that one over there, because that'd be a lot easier if I could just reuse what's here. And while I was at it, I had to break apart the wire chain here and pulled out everything we didn't need and installed the DMM cables. I didn't show them, but they're on the x-axis too. They had to kind of snake up through. But everything's coming out here, ready to go through this chain, and I think I have everything I need to go through all these chains. So once I clean this one out, I can button those up, and then that'll be done. So I think the next thing is going to get this mounted. Probably do Z first, and then Y. I don't know how I got my measurements wrong, but the Y-axis is going to sit about here, and you can see that rubber stopper comes up a little short. So, but based on the limit switch, I'm going to lose about a ½ inch, 3/4 inch, maybe. This bumper is supposed to be beyond that, so that if you blow past the limit switch, you bump up against this and not like some sort of hard stop. So I have to sort that out. But I hope on this end, because I still have a little bit of ways to go down there. I might be able to pick up another 3/4 inch or an inch on this side. So hopefully overall no total loss of travel. But even if there is, switching to the servos I think will be worth it. I could have went with a smaller servo here, and definitely on the Z. I don't know why I didn't. I just bought 3 matching units. But I probably could have got away with smaller ones. But that's okay. At least they won't be overworked. We'll sort it out. It'll still be usable. Okay, so that's next. So as you can see, we got the Z-axis motor mounting plate finished. Was able to salvage the original one, which was good. Really all I had to do was this center hole was larger, so I hogged that out for the bigger size that's on this motor. And the bolt holes were in the same place, but the bolts that were in here were small, and the heads pulled right through the right through the holes that are in the motor. So I had to go up on the bolt size, which was okay, so I just drilled it out and retapped it. If I was paying more attention when I ordered this stuff, I probably would have got a different motor for Z, and also for Y. But for Z, it's too tall for where it's at. It was actually hitting this cable chain, I guess. So I had to put these little spacers in here, 1/2 inch spacers, to raise it up. But I was able to push the pulley further down on this motor than it was on the other one. That's after I got it drilled out for the larger size and put the keyway in it. And on this pulley, I had to raise it up probably about 1/4 to 3/8. And you can see the shafts. It's still mostly on the shaft. There's not much stick up, so I don't think that's going to be an issue. But we're good to go there, nice and tight. Actually, it's probably a little too tight. Might need to. No, that's about right. I should probably grease this lead screw before I mess around with it too much. Also got all the wires out that didn't need to be in here, so I kept the 2 coolant lines, the 1 air line for the spindle, and the spindle wiring cable, power cable, and of course the limit switches. But all the other stuff came out. So I got all that tidied up. That's good to go. The y-axis, same thing. I was able to reuse the plate, so that was good. Ran out of bolts, so I've only got it mounted with 2, but that's okay because it still needs to be. I still need to get the y-axis lead screw sorted out and remounted, so I can't even tighten that up anyway. But I have to make an adapter right here, similar to what I did on the X, to hold the lead nut. That shouldn't be too big a deal since I already did one. I just kind of alter it to match this situation. So coming out of here, obviously this is sticking out too far. I gotta pull it through. But I got the big cable tray, cable chain, whatever it's called. Got that one full of wires, and everything we need is coming out right here. So it's actually this cover goes over top of this. Originally came out of here with a big fitting and went through this huge wire that went to some computer that was mounted somewhere separate. Actually, that computer box right there. So I don't know, maybe you put it on a card or a desk or something or whatever. That's how it was originally. I don't want to do that on this. I don't want the computer to be separate. On the hard-hinge lathe, which you can see right there, the computer's mounted on a little pedestal, and you stand at the machine and you do whatever you need to do. I thought about doing that to this, putting it on a pedestal and having the monitor and stuff up high, and I was gonna make a box down here for everything else, and just have the monitor and the hardware, or the monitor and the keyboard and mouse and everything up high. But I was concerned because this table's, if I'm be cutting aluminum, I'm going to have to run some sort of a coolant so the bits don't gum up. The table's made for coolant. It's got these big troughs and these drain hoses, which I found. I couldn't find them earlier when I was looking, but they come out. You can't see that, but they come out in the corner here, and they go down to these drains. And if anything gets wet, it's going to cause problems, especially the motor drivers and stuff. So I'm trying to come up with a different solution, and I don't want it to take up any unnecessary space. So let me grab something. I'll show you what I came up with. So what I've come up with, and I'm not 100% on it. I'm about 80%. Still working my way there. Got these wires coming out here, and that's fine. I could change that if I wanted, but it's kind of convenient. And what I'm thinking about doing on this side, because this will be the front of the machine, it's not going to live here. It's just here while I work on it. I have some 2x6 aluminum square tube, and if you look, this cable tray on the front is about 6 inches. So what I'm thinking is, if I can mount this here, maybe 3 or 4 bolts here, 3 or 4 bolts in here, and of course the end cover butts up against this, so I'd have to be mindful of that. And it wouldn't go all the way to the floor. It would stop, right here at the bottom of this. Cut a hand hole so I can pull wires through, fish them up. Put another hand hole here so I can fish wires this way. And then up top here, fabricate box, not out of cardboard. I just happen to have a 10 by 10 box that I was using for sizing, and obviously this gantry moves, and it stops just shy of that, which is convenient. If I could mount this maybe 2 or 3 inches above the gantry, right? So starting here, 48 inches, unfortunately, is a little short of going the entire distance. But on this end, since there's no cables going through it, I don't have to use rectangle tube. I can use this piece of square tube that I have laying around, which, interesting, it works out. It's the same depth as this thickness here, so it won't make the machine any deeper front to back. When you have a shop like mine and you're counting every inch, that kind of silly stuff matters. So 2 uprights, rectangle here, square over here, and maybe 2 crossbars, probably some square tube or something, so that I can mount this and have support going all the way across. Now with this being 4 foot wide, it'll be plenty big enough for those 3 drivers, the breakout board that's in that box there, and the VFD is about the same size as that box right there. Obviously some miscellaneous breakers and the computer itself. Probably just take a desktop and blow it apart. Take all the pieces out so it'll fit. I don't think, no, the tower wouldn't fit in something like that. But I can do that, that's okay. So that's what I'm thinking. I'm not completely sold on it yet. I think what I want to do is go ahead and cut these tubes and mount them. These tubes have been around for at least 10 years. So if I end up trashing them, it's not a huge loss. Just been kind of kicking them around. And at the very worst, what I'll have is a couple holes in these flanges. And that would be the worst damage to the machine if I change my mind and don't like it. But I think it's going to work. An added advantage, if I have this box mounted here on the end, which would be right here, I can make a panel to mount all my buttons and switches. The e-stop, power up, reset, spindle reset, manual overrides, cool it, whatever. I can mount it all right here on this end panel, because like I said, this will be the front of the machine. And then I can mount the monitor either on top, which I'm kind of tall, so it wouldn't be uncomfortable to see it, or I can put it, on the face or something. Not quite sure, but I think it'll work out. The first step is going to be getting these mounted and getting some crossbars on here, which I'm going to have to weld, which is a bummer because I can't really weld, much less weld aluminum. I have this stuff, it's never turned out well. But gotta do it, I guess. Gotta learn. So let's just stop talking about it and do it, I guess. Yeah, let's just do it. So I've been pretty busy working away on this and forgot to pick up the camera. Anyway, I got the cover on, which means I had to cut that little piece of the lead screw off, and I'm going to use it to test out to see how easy it is to machine, just in case I have to replace the one on the y-axis. I also have I built this. This is 2x6 rectangle tube. I just drilled through the plate that's behind here and bolted it in place. 3 bolts on each side should be sufficient. And of course, it also acts as a wireway. So I had to make a little filler piece to go right here for the wires coming out of here, and they'll go up It'll come through here and then go into the main box, which is I'll show you from the other side too. It's a little easier to see. So on this side, it's a little short for two reasons. One, this is 48-inch sheet. And that's all I had, so it only runs 48-inch. But using that to my advantage, I'm going to take this breaker box and mount it on the outside right here. So I try to keep everything within a footprint so that there's no wasted space or unnecessary. The thing's not unnecessarily larger than it should be. An example of that would be when I was making this frame here, which don't look at my welds. Oh my goodness, thing kicked my butt. I'm not that great at welding anyway, but the aluminum really worked me over. Anyway, one of the key things I wanted was to make sure that any legs that I put didn't protrude past the carriage. On either side, really, I've got a space issue in the shop, as if you've watched any of the shop videos, I'm sure you've noticed. So, mounting that on the outside saves room inside the box. It also makes it easy to get to in case I need to turn it on and off. And it also doesn't push it past this arbitrary end that I've made here. So in addition to the breaker box, I also picked up a shut-off switch, a couple breakers, transformer, just some things to make the electrical work. So let me show you this. This is recessed. I think it's 1.5 inches, maybe 2 inches. And the goal here is to mount my switches and stuff here. So the main shut-off will probably be here. E-stop up top where it's easy to get to. And then whatever toggle switches I might need on this side. And everything would be behind this plane here. So nothing sticks out. If you're walking past it, you shouldn't snag anything. Easy to get to. Goes right into the box. Not sure about the monitor yet. That sits a little high. I could just take this off and make some kind of mount. Drop it down, or maybe I'll mount it to the face. Not 100% yet. But let's go around to the other side. I'll show you the inside of the cabinet. At the moment, it's not a terribly lot to show. You can see the wires coming in over there. I got a panel made here for the drivers to mount to, and I did drill and tap these, but I think I'm gonna over drill them and put some rib nuts in them just so they're stronger. This is only 080 aluminum, and these drivers stick out a good way, and I wouldn't call them light. I just want to make sure we don't lose anything. So I've got a divider here. And the idea is I'm going to use this side as the power box side. And you can see I've got one hole drilled here for wires, but I'm going to drill another one for air because I'm going to put a fan on this side beside the breaker box. Kind of in a vent somewhere over here, probably behind where the drivers mount, to pull air in and kind of pull air this way and out. So this will be the power box side. Obviously the breaker will be outside, the big breaker, but then we'll have the small breakers, the VFD, the small power supply, just miscellaneous, whatever I need to get the juice flowing. Then everything over here, I guess, will be like the logic side. So the drivers will be there. I got another panel broke form somewhere. It's for the breakout board. I'll probably go right beside it, leaving this space over here for the computer. I've got an old desktop. I think I'm just gonna blow it apart and pull all the necessary pieces out and maybe mount it here or somewhere. And I left a space behind this to act as a wireway. It's because the power is going to come through and it has to go to something. Obviously, the power wire for the spindle is going to go straight out and down to the cable that's already run. Power coming to various items, I can put it behind the panel and kind of bring it around to the front. It's a little bit of wire management, so hopefully that'll work out. And then got some faces that'll go on here. I'll just kind of protect this from, hopefully, dirt and dust and chips and all that stuff. So that's where I'm at right now. I think I have everything I need to start getting the power run. So that's where I'm going to start. I'm going to drill a couple more holes, for one for a fan, another for air to get through here, and then a hole for the power to come in, all that stuff. And I'm going to start, I think, on this end, mounting, and work my way across. So that's what I'm going to do. Well, here's an update. If this cabinet looks different, it's because it's packed full of stuff. I kind of broke the electrical stuff out into a separate video. I just wanted... When I first did my first one, I was scared. I was intimidated by the electrical. And I thought if I could just show a step-by-step of what I did with this one, maybe it could help somebody to see that if you just take it one bite at a time, you'll get there. But anyway, here we go. The only thing that's missing from this side is maybe a power supply for the computer. If I can find one small enough to stick right there, I can put the motherboard and the hard drive right here. Everything will be in this box. That's what I want. So hopefully I can find that. Obviously there's some wire management here to do, but the spindle I got it on a low frequency because this thing's got like an air blasting that keeps it cool. I don't want to burn it up playing around with it. But anyway, that's working. So all I got to do is get that to talk to the breakout board, and the spindle will be ready to go, automatic. The axes, I have not dialed them in 100% yet. I got them pretty close just with a tape measure. Pretty cool, right? Okay. No limit switches, no e-stop yet. Still working on that. But getting there. I've noticed when it changes directions, it's got a bit of a bump. I don't know if maybe it's going too fast. Running it at 200 inches a minute. I don't know. I'm going to grease them down a little bit. Check the ball screws and everything. Make sure there's no junk on them. I may have to slow that down. 200 a little fast. Actually, I don't know for cutting wood and plastic. It's not something I really do. I have to check into it. But for some reason, when it changes direction, it's got a little bit of a... And I don't know if it's inaccurate because I'm not cutting anything or if it's just vibrating the machine. But we'll sort that out. No big deal. So, getting there. Getting close. At the moment, it is functional. I can use it. Not the way I want to use it. Obviously, I mean, I'd have to turn the spindle on by itself, and it's not that accurate. But we're getting there. One step at a time. Once I get all this done, I can close this up for good. Do my final tweaks on Mach 3. We'll do a test cut and see how it looks. It's pretty cool. We'll jump forward a little bit on this project, and as you can see, I've been making a few chips. Just recently got it moved to its new location, right here beside the Herco. I put it here because they were about the same depth, just to make a even pathway, whatever. Put some controls here on the end. Let me fire this up and show you. This is the main on-off switch. And right now I just have the monitor mounted up here. Blue button turns the computer on. So while that's firing up, this piece right here was actually the first project I made on it. It's just some, let's say it's 063 aluminum that I cut the shape and then folded up and attached to the bottom of this mount that holds the keyboard and a little pad for the mouse. So let's see here, we're firing up. I've got a bunch of test files here, stuff I was playing around with. Alright, so there's our Mach 3 screen. There's our e-stop. These aren't labeled yet, but I just happen to know what they are. That turns on the drivers. And let's reset it. Let's check it out. I could probably speed up the homing speed a little. It's kind of slow. But normally I turn it on and walk away, so it hasn't been an issue yet, but I don't have a lot of hours on it either. So while it's doing that, I've got a toggle switch here. There's actually I don't know if it's called a three-way or what, but it's on, off, and then also on. So on the back of this, and I'll try to insert a little clip of it if I can get back there and show you what I'm talking about. But on the back of this I have two outlets, and my plan is to use one for vacuum and one for coolant, but they're both going to use M7 to turn on. So if I'm cutting a part that needs a vacuum, I have to remember to turn the toggle switch to vacuum, or the opposite, coolant, and I got to remember to turn it down to coolant. Which I'm still trying to figure out how I can run some coolant but still have a spoil board. This MDF obviously won't work, but cutting aluminum, you need some type of coolant to keep it from gumming up. I'm thinking PVC sheet, if I can find a piece that's not ridiculously priced. I got a USB plug in here. What else can I show you? Well, I'll show you some. Now right now the fastest I'm running this thing is about 170 inches per minute. Now I had it cranked up when I first set it up. I want to say I was pushing close to 600 inches per minute, but the baud rate on the computer was too slow and it just kept erroring out. So I backed it down, and I started to get a little bummed out, but then I realized 600 inches a minute for a gantry this size that's all cast aluminum and has some real weight to it. I don't know if I want that much weight whipping around for my rapids. So it's a compromise, but I think we'll be okay. So the part I was making here, you can see the chips. It's actually an aluminum door panel for a Volkswagen, and I got a little bit of footage of it engraving these lines, and I'll put that right here. And I can't remember if I got any footage of it actually cutting through. If I did, I'll put it here. If not, it's the same process as engraving. It just goes all the way through. So I did test cuts in aluminum. This, like I said, it's 090. Worked out fine. Just need some coolant. I also cut a little bit of plastic and and I cut some wood, but I don't see any of that laying around. But anyway, this turned out pretty good. Pretty happy with that. So I guess that's pretty much it. Maybe I put an air line down here for the spindle. Well, just an inlet. It goes inside of here, which comes up to here. I added a fan to well, you saw the fan. I added a filter to the back. I cut a hole out behind the drivers to draw air in there, and it goes through this whole thing. But anyway, that's pretty much it. Hopefully there'll be some. So, oh, you know what? There is one more thing. The reason I use M8 for both of the coolants is there's an air solenoid for the spindle, and I use an M7 for that. And I put a light here to remind myself. I don't have the compressor on, so it's not going to make any noise. But that light tells you that the solenoid is on, it's letting the air through, it's cooling the spindle. So that's what this light is, and that is why I had to put both coolants on that toggle switch. Alright, so I guess that's it. This project is probably 98% done. I might have a few tweaks to do, like some coolant or something. But time for some totals. Let me I have it saved in an Excel file. Let me pull that up and I'll give you the skinny. Like I said, full disclosure, I'll tell you what everything cost and how long it took me to do it. So I'll check that out and be right back. So according to the files I have, all in, as it sits, making parts, 98% complete, 4,600 and some change, like 4,640, something like that. But that's remembering that I had some of this stuff. I had this aluminum laying around, same thing with that, monitor, keyboard, mouse, goofy stuff like that. The machine itself was $1,500, so the conversion about $3,100. Not too bad, considering I replaced all the electronics. As far as the conversion goes, if I had reused the motors that were in here, if I didn't upgrade to the AC servos, if I had reused the motors that were in here, I could have used slightly cheaper boards and stuff, like Gecko drivers and maybe a PMDX board or something, and I would have saved about $1,000. So for a machine like this, somewhere between $2,100 and $3,100 to do what I did to mine, just depending on the options you choose and all that. And I'll probably put another $200 into it, maybe, with a cooling system. I actually have a little mist cooler. I don't even know where it is, or I'd show it to you, but it's, anyway, you've seen them before. It's got the little bucket and it's supposed to be like a minimum quantity mister, but I already have that, so I wouldn't have to buy that. But just miscellaneous parts to hook it all up and everything. So anyway, all in about $4,600. Now as far as time, I kind of loose with the hours as I was tracking it, because I was doing other stuff too, so I was kind of bouncing back and forth, but I tried to keep as accurate as I could, and it was right around 40 hours. So if I had nothing else on my plate and I was just going to take a week off and plow through this thing, I would have been able to do it with no problem. It might actually have even been less than 40 hours. Because I'm sure I wasted time starting and stopping and all that stuff. So that's it. That's what the conversion cost for me on this, and that's how much time it took. I have a separate video where I kind of walk through the electronics a little more in detail. I did that because when I did my first conversion, I really couldn't find anything kind of like that to give me confidence that I could do it myself. So I figured I'm recording me doing stuff anyway. I might as well just do it. Hopefully it'll help somebody. But anyway, if you want to check that out, I'll put a link somewhere. It's just kind of more of this. But anyway, that's where it's at. Hope to have some parts coming off it soon. Appreciate you watching. See you next time.